Hello students, in the previous section we have discussed distance and displacement. In this particular episode we will be discussing some very interesting questions based on distance and displacement, right? So let's start with the first question. Suppose an athlete or a person starts running along a circular path of radius r. Suppose this is a circular track, say of radius r. This is the center and its radius is r. Suppose an athlete starts from point A and he starts moving or rather running along the circular track and completes one turn and eventually comes back to point A. So what will be its distance in this case during the entire trip? So distance, as we are aware, is the length of the actual path covered by the body. So in this case the athlete has covered one revolution. So he has started from point A and after following the circular path he has again come back at point A. This is one complete revolution, right? So distance would be length of the total path covered, which in this case would be the circumference of the circular track, and circumference of the circular track of radius r is 2 pi r. Now what about the displacement in this case? Displacement is the shortest distance between the initial and the final position. Over here A is the initial position and A is itself the final position. So both initial and final position coincides. So as I have told you, whenever initial and final position coincides, then the displacement is always 0. So that's first case. Let's consider the second scenario, right? Suppose this athlete starts from point A and instead of completing the whole track, he comes at point B, which is diametrically opposite to that of point A. It is diametrically opposite to that of point A, right? So an athlete starts from point A and then he finally reaches at point B. So here A is the initial position and B is the final position. In this case, distance would be this is the length of the actual path covered. It is the semicircular path. A is the initial point, B is the final point. So half the circumference of the circle, 2 pi r divided by 2, that will give us pi r. This will be the distance, length of the actual path covered. Now what about the displacement in this case? Displacement would be the shortest distance between the initial and the final position. And as I have told you, it is represented by an arrow. Tail should coincide with the initial position and arrowhead should be pointed at the final position. So the displacement should be like this. It will be the diameter. It will be a straight line connecting A to B. So it is obviously the diameter, which is equal to twice the radius. So in this case, this will be the displacement. Consider third case. Let us assume the athlete starts from point A and following the track, he reaches point B. After which, suppose the athlete feels uncomfortable, he is unable to finish the race, and then he eventually walks along this straight path and reaches point A. So this is the path which he follows. The athlete starts from point A, follows the semicircular path and then moves along the straight path BA and eventually again reaches point A. So what will be the distance in this case? In this case, the distance covered by the athlete would be, again, length of the actual path. This one, it would be equal to pi r plus the length of this path, which is the diameter, it is equal to 2r. Therefore, r can be taken as common, it would be pi plus 2. So this is the actual distance covered by the athlete when he follows this path, right? What about displacement? Again, the athlete starts from point A and eventually reaches point A. So initial and final position coincides. So therefore, displacement would be 0. Displacement in this case would be obviously 0. Consider the fourth scenario. Let us consider an athlete starts from point A and he completes one revolution, maybe in 40 seconds, right? And he moves with a uniform speed, means his speed is constant. So he completes one revolution in 40 seconds. So our objective is to find out the distance and displacement at different instants of time. Say after t equals to 10 seconds, what will be the distance and displacement? After t equals to 80 seconds, what will be the distance and displacement? So let's do it. Suppose the athlete starts from point A and is able to complete the circular path, one revolution in 40 seconds. And since he possesses uniform speed, right? Therefore, it can be divided into 4 parts. So if it starts from near point A, which is considered the initial time, initially, that is at t equals 0, this point, which will be the midpoint of A and B, this will be 10 seconds, this will be 20 seconds, this will be 30 seconds, and this will be 40 seconds. Again, this will be 50 seconds, this will be 60 seconds, this will be 70 seconds, and this will be 80 seconds. So in 80 seconds, we will be able to complete 2 revolutions, or we will be able to complete 2 turns of the circular track. Now the question is, what will be the distance and displacement of the athlete after t equals to 2 seconds? Say after t equals to 10 seconds. So question is, an athlete having uniform speed moves along the circular track and is able to complete one round in 40 seconds. So what will be the distance and displacement after t equals to 10 seconds after his start? So after 10 seconds, if the athlete starts from this point, he will be able to reach this particular point. So this will be the initial position and this will be the final position. And this is the length of the actual path covered. So length of the actual path covered, that will be the distance. So distance in this case would be equal to this part. It is 1/4 of the total circumference. That is 1/4 of the total circumference of the circular path. So it will be equal to pi r divided by 2. This will be the distance. Now what about the displacement after 10 seconds? Displacement would be, this is the initial position, this is the final position. So you need to draw an arrow. It's a straight line between these 2 points. The tail should coincide with the initial position, while the arrowhead should point towards the final position. Now look, it's a right angled triangle, isn't it? This is r, this is also radius. So displacement is this one, which can be given by the hypotenuse of this right angled triangle, right? So displacement would be square root of, make use of the Pythagoras theorem. Hypotenuse is equal to square root of base square plus perpendicular square. So this is base, this is perpendicular, this is hypotenuse. So displacement will be square root of base square plus perpendicular square. So it is square root of 2r square, which in turn would give us root 2r. So these are some of the questions which you can easily try. These are some very basic questions, right? So let's consider some other examples as well. Let's consider a cube, maybe of side 10 meter. Let us consider a cube of side 10 meter. This is a cube. Its side is given to be 10 meter. Let us assume it. There is a room in the shape of a cube having side of 10 meter. All the sides are equal in a cube. Suppose a fly starts from one corner and reaches the diametrically opposite corner of the cubical room following zigzag path. Suppose this is one of the corner and this is the diametrically opposite corner. These are the 2 diametrically opposite corners. Similarly, these are the 2 diametrically opposite corners. So my question is, there is a room in the form of a cubical shape of side 10 meter, right? A fly, an insect, a mosquito, whatever. A fly starts from point A, from one corner, and following a zigzag path, it reaches the opposite corner of the room. What will be its displacement? What will be its displacement? In this case, displacement, as we are aware, again I am telling you, it's a vector quantity. means it possesses both magnitude as well as direction, and it is represented by an arrow, the tail of which should coincide with the initial position and the arrowhead should point towards the final position. So this will be the shortest distance in this particular direction. So this will be the displacement. So as it's pretty evident from the diagram, actually displacement would be equal to the cube of this, would be equal to the diagonal of this cubical room. So displacement in this case would be diagonal of this cubical room, and diagonal of a cube is given by root 3 into side. This is the formula for the diagonal of a cube. Diagonal of a cube is given by root 3 into side. This is the formula. Diagonal of a square is root 2 into side. Diagonal of a cube is root 3 multiplied by side. So it is root 3 multiplied by 10, or it can be written as 10 root 3 meter. That is 10 root 3 is 1.732. So it will be 17.32 meters. That's the displacement, right? Let's consider another example. Third one. Here we will consider the directions north, south, west, east. Suppose a body, a person moves 8 meter towards east and then he turns towards his left and moves 6 meter towards north. What will be the distance and the displacement covered by the body? Right? Let us represent it diagrammatically. So, this is north, this is south, this is west, and this is east. Now listen to the question. Question is basically a person, let's say, starts from point O. He moves 8 meter towards east, due east, 8 meter due east. And then on reaching point A, he turns towards left and starts moving straight towards north, covering a distance of 6 meters. So this is B, this is 6 meters. So what will be the distance and the displacement in this particular case? Obviously, distance is the length of the actual path covered, which will be 8 plus 6. This is the length of the actual path covered. So it will be equal to 14 meters, isn't it? What about displacement? Displacement will be given by the shortest possible distance between the initial and the final position, and it should be in a unique direction obviously. This will be the displacement. Again, it's a right angled triangle. So we can very much make use of Pythagoras theorem. So the displacement will be given by square root of 8 square plus 6 square. It will be equal to 64 plus 36, which will be 100. It will be equal to 10 meters. Clear? So this was the question regarding direction. Let us discuss some other question. I am slowly and steadily increasing the level. Now, next question. It's again a very interesting one. Suppose a person starts from the origin and he moves 20 meter towards north. A person starts from the origin and moves 20 meter towards north. He then turns towards his right and moves 10 meter towards east. Then he again turns and moves 20 root 2 meter towards southwest. 20 root 2 meter towards southwest. So what will be his distance and displacement? Okay, I'll repeat the question, right? A person starts from origin and suppose he moves 20 meter towards north. Then he turns towards right, A to B, and moves 10 meter due east. And finally he again turns and moves a distance of 20√2 meter along southwest. What will be the distance and displacement of the person? Southwest, look, this is the direction. It is north, south, west, east, right? It's in a horizontal plane. These are the geographical north, south, west, east. Now, you can draw a line over here. Angle bisector. So this is 90. So angle bisector, it would be 45 degree. It would be 45 degree. This is 45 degree. So this is known as northeast. This will be known as southwest. Understood? This one will be northwest. This one will be southeast. So that's the direction. This is just to give you a basic idea. Let's deal with this particular question. So, the question is, this is the origin. This is north, south, west, east. The person starts from origin and he moves 20 meters towards north. Suppose O2A. This is 20 meters. This is 20 meters, right? Then A to B, 10 meters towards east. 10 meters. This is 20. So 10 would be half of this. So somewhat over here. A to B towards east. This is 10 meters towards east. This is 20 meters, right? And then 20√2 meters southwest. Now what we'll do is, here represented by dotted line. This is north, this is south, this will be west, and that will be east. So, southwest, this will be north, south, west, east. Southwest would be along this line. Just now I told you. So this angle would be 45 degree. So finally the body would move along this direction. So finally the body will move along this direction. This is the direction along which the body will tend to move. And it moves along this direction up to a distance of 20√2 meter. Now, let's make use of some mathematical concepts, right? This angle is 45 degree, this angle is 90 degree. Making use of angle sum property, we are aware the sum of the three angles of a triangle is 180 degree. So, this needs to be 45 degree. Now look, this is an isosceles triangle. These two sides are equal. So, it is 10 meter, this would be also 10 meter. These two angles are equal. Therefore, sides opposite to the equal angles of a triangle must be also equal. 10, 10, it's a right angle triangle. So what will be the hypotenuse? Make use of Pythagoras theorem. So you get 10√2. Square root of 10, you will get this now. Square root of 10 square plus 10 square. So it will be equal to 10√2. Right? So this is 10, this is 10. So the hypotenuse will be 10√2 meter. So up to here, it is 10√2 meter. But he has covered a distance of 20√2 meter towards southwest. So he will continue along this path. Now what happens is that this is 45 degree. This will be also 45 degree. These are vertically opposite angles. This is 90 degree. So if you connect it, this one will also become 45 degree. Again, these two sides must be equal. The entire distance is 20 meter. So this must be the midpoint. AC must be equal to CO. Each should be equal to 10 meter. Right? Now this is 10 and this must be also equal. 45, 45. It's a right angled triangle and these two angles are equal. Right angled isosceles triangle. So these two sides must be also equal. So again, this is right angled triangle. This is 10, this is 10. This is perpendicular, this is base. So hypotenuse can be again found by using this. So this distance will be 10√2 meter. 10√2 plus 10√2, it would be 20√2. So the body, when it starts moving from point B along southwest, moving a distance of 20√2 meter, he should stop at this particular point. This is his final destination, point D. Right? So question is, O2A, it is moving 20 meter, 10 plus 10. It is moving 20 meter towards north, then 10 meter towards east, and then 20√2 meter towards southwest. So this is the initial position and this is the final position. So displacement will be this one. So displacement of the body would be 10 meter, direction towards west. This is the complete answer. If this is taken positive direction, this can be taken as negative. So you can write minus 10. Minus will indicate that towards west if this is taken as positive x direction, right? So this is the displacement. Numerical value which indicates its magnitude, this indicates its direction. And if you want to find out the distance, it is the length of the actual path covered. So it will be 20 plus 10 plus 20 root 2. So distance would be 20 meter plus 10 meter plus 20 root 2. So it will be 30 plus 20 root 2 meters. This will be the distance and this will be the displacement. So it was a very good question. Let us try another very interesting question. It's a case of a wheel. Let us consider a wheel of radius r. That is given. A wheel of radius r. A wheel or ring you can consider that is given to be of radius r. This is the wheel or a ring of radius r. This is suppose the center. So its radius is r. And this is the surface of contact. This is surface of contact. Suppose this point is A. And suppose this point is B. Right? It is held stationary. If it is given a small push, it will start moving in the forward direction. So what we are supposed to do is, you are supposed to find out the displacement of this point after half the revolution. After half the revolution. Right? So my question is, this is a ring of radius r lying at rest on a horizontal surface. On giving a slight push, obviously this ring will start moving in the forward direction. So this point A, which is initially in contact with the ground, you are supposed to find the displacement of this point A after this ring has covered half the revolution. Half the revolution. So this is the ring. As it rotates, it will tend to move forward, isn't it? So after half revolution, the diagram would be somewhat like this. I will represent it with dotted lines. It will be somewhat like this. This is the diagram after half the revolution. So point A, if this moves like this, it is moving in the forward direction. So point A will go in the, point AB will tend to interchange their position. Now point B will come in contact with the ground. So this will be the diagram. And in half the revolution, it will cover what distance? Pi r. This you are aware. If you consider a wheel, during one complete revolution, it traverses a linear distance of 2 pi r. Therefore, during half revolution, it will cover half the distance or same perimeter of the circle, which is pi r. Understood now? So, during half the revolution, as the ring moves forward, it traverses a linear distance of pi r. It is not stationary. It is not rotating about its own axis. In fact, it is moving forward. So, during half revolution, it covers a linear distance of pi r. So, point A and B will interchange their position after half the revolution. Look like this. This is point A, this is point B. So, as it revolves, it will be like this. Right? So, this is the initial position of point A and this is the final position of point A. So, what will be the displacement? This straight line. This straight line. This will be the displacement. It will be represented by the shortest possible distance between the initial and the final position. So this is the displacement. So let's evaluate it. This one is r, this is also r, so this will be the diameter 2r, right? And this distance covered, as I told you, it is equal to pi r. So as you can see, if you join this line, it's a right angle triangle. So you can very much make use of Pythagoras theorem. So displacement would be square root of base square plus perpendicular square. That is 2r plus this distance is 2r and this distance is y. So it is equal to r can be taken common, so 4 plus 5 square. This is the answer. So this was again a very interesting question. So students, I hope whatever questions we have discussed related to distance and displacement, that must be very much clear to you. Now it's your turn to practice more and more questions based on this concept.